Hello, in this tutorial we will continue working on our dashboard where we will create the descriptive statistics tab. So here we will create 4 different visualizations. First we will start from the backend, preparing the data. For the visualizations we will calculate some simple descriptive statistics such as mean, average of the values, and we will use libraries, pandas and NumPy. We will create several APIs for getting the data for the front end. After we finish this, we will continue with the front end where we will create 4 different visualizations components. One of them will use the Plotly visualization library. 2 of them will use Angular material tables. And one of them will use one more time Apache eChart graph chart. So let's start for the backend, preparing the data first for the first component where we want to make a histogram for age and for other variables such as RUP index. Okay, so we start from the backend. Here's our backend. So we go to our patient. So here we will prepare the data. We call it a bar chart because we will use a bar chart there from Plotly. So I will already have a ready method. We just go through. So we have here the data, a year and a region, because we always have this filtering, right? We want to throw either for all regions and for specific year, or for specific year and specific region. So we check if the region is not all, it means some specific region. So we have to filter the data by that region. And we know that region name is located in a municipality column. So we just, by this line, we filter out, the data for specific region. In case if it's not specific region, we do not do this. We just filter out by year. We also remove some duplicates, and then we have to group by. Since we want to do in our interactions, we want to have to show the number of individuals per age and per group, so we use have to group by it. So this help us first to this command value accounts will have unique index, which is age, and for each age unique value it will calculate amount of individuals, and then we sort it. So we want to sort it also to have it sorted value from small to large. The same we do for the RUP index here. Then we prepare a data for the Angular bar chart. So Angular bar chart, in Angular we have a Plotly, and in Plotly it needs to have a data for x-axis and for y-axis. So as we can see, we have for the age, we have the x will be the age, and the y will be the number of individuals here, number of patients per age. The same for the RUP data, and then we have returned a response like this. So we return 2 as a JSON object with the 2 data prepared for the age chart and for the RUP chart and the RUP data, age and RUP data, and we return the response. So we have it in the patient, and now we have to create the endpoint to get this data so that our Angular can get it. And I already have it ready. Okay, so I created with a name get data for the bar chart, and it's a post because we will receive the year and region from the data. So we parse data from JSON, and we use our method that we just have created, yeah? Here. And return as a JSON object back. Now we will restart it, and we already have ready data for our bar chart in Angular. Now we will go to front end and we'll create a component to that bar chart. Okay. So where we have our front end is here. So in our front end, we will create one more component called descriptive statistic. Okay. Descriptive statistic. Generate. We need to provide component name. Component. Okay. And then we will need to generate one more and generate component. Yeah, a bar chart, for example. So we generate two components. Why? I will explain you in a second. So first we have generated the descriptive statistic component, which is this one, and it's not showing yet. So it will contain 4 different components inside, 4 different visualizations. So this will be like a main component in the descriptive statistics. So if we go to the main in descriptive statistics, so we have to specify that we will use our app descriptive statistic. Yes. How do I know this name? Yeah. So if I go to descriptive statistic, and this is a selector, this is a name of this component. So it should be exactly the same here. If I want to use or insert this, embedded this component in some page. So now inside of this descriptive statistic component, we can check it's already will work. It has an error because I forgot we have to import it here all the time. We have to import this descriptive component. Okay. So now it's working fine. So here descriptive statistic works. In the descriptive statistic, we want to have 4 different visualization. So for this, I will use in Angular material, we have called a grid. So if you go to the grid component, yeah, so this is how I also want to create. We have like, we will divide our page on the 4 regions, and each of them will have its own visualization. And this is how it works. So we define the mud grid list. We will have 2 columns because we only have 2 columns, but we will have 2 rows. We have 2 columns. The row height we define here as a row height. And then we say, okay, we want to have a double row here. Then it will be 600 pixels, 1 row. And we will put here our up bar chart component that we have it here. We haven't created these components yet. It doesn't exist yet, so I will comment them for the moment. Okay. We have here a class border. So I have created a class to separate this, to see the separation of this grid borders. Yeah. So this is how it looks like. Okay. The error is it's because I need to import the mud grid list module. Okay. Something else I'm missing. Up bar chart also. Chart bar chart component also. Okay. Now it's fine. Okay. So now we have created a list of, as you see, we divided it on 4 different areas. And here our bar chart that we will place it. Yeah, here's already we have our component. These ones are empty yet. So if we go to the bar chart now, we are working on the bar chart component. Yeah, it shows bar chart works. In the bar chart component, first we will have the select, where we can select user to be able to select either the H or RUB index. So first we will add a div which will have a class. Didn't have a class for it. Okay. I have to select distribution, yeah, or select variable, and then it will be H or RUB index, yeah, battle RUB index. And here we have this bar chart from a Plotly library. So when we use a Plotly library, we specify it like this, and we have to specify the data and the layout, yeah, what type of graph chart it will be. So they are red because they are not known in our TypeScript file. Yeah, here we have a logic of this component. Yeah. So here we would need to first enter the Plotly module. We have to import the Plotly module first. Okay. And we also need to do it like this. For the Plotly in Angular to make it work, because it's JavaScript. I need to install it. It doesn't exist yet. Okay, I need to install this one. If we go to Plotly npm install Plotly, yes, this one. Okay. Stop it and we'll install it. Okay. Should be visible now. Still can't find it. Yeah. Go to our package JSON. We have Plotly JS dist min. That's correct. So if we go here, should be, doesn't see it. Okay, we will maybe just, yeah. Okay. We also need to add here the select component, because whenever we use this is mat select component from Angular material, so we have to import it, a module of it. Okay, we will come back to this later, why it's not working. It should work. Maybe I should also add somewhere in the app configuration. No. Okay, in the app component, no. Okay, let's have a look when I was, go back again. I don't know, we will do it also this just in case. Okay, this solved that one. Very good. So let's continue. Yes, so now we have here chart data and chart layout is unknown variables, so we have to create them. So the chart data will be as an array, and the layout will be an object, which is options defined in the chart. Then we will have different options. We will have for H options, which will have X and Y data. It will a bar type, a bar chart, and the name will be H distribution, RUP index distribution. This is already two options for the bar chart. Then selected variable by default is H, so the first one will be H. So we will use this H as default. So we're still missing update chart function when we change the select. Okay, so now we will have the constructor here. So inside of the constructor, we import two services that we have. No, that was wrong. Patient service. I don't have a patient. We have a. How did we name it? We have to create a patient service. We will create a patient service, and setting service we have. Let's generate services patient. So now we have patient service. So we subscribe here in the settings all the time. If you go to the settings, in every visualization component, we subscribe to this settings object, which means whenever we change it, we will always get a new value, the changed value. So this will get us a new value of the year and region, and we will request a new data from our backend using the get bar chart data, the patient service. So if we go to our patient service, so we will need to have again the server URL, and so just copy this. Our URL is like this. Okay, individuals. We don't need for the moment individual events data. We will edit it later. So headers. So in the constructor we have to import the HTTP client because we will use it to send our post and get requests to the server. And we will have this method which will get data. So get chart data, year and region. So we will use the same, exactly the same name as we have it in our backend. If you go to our backend, we go to our backend, so it is exactly the same name as in our front end here. And we have in the body, we have a JSON object which says year and region. These are headers. So coming back to our, so we will get the data from a server in this object result, and result will contain already two different that we already have seen how we prepare them on the backend, and then we'll see, okay, if we've selected H, we show the H data. If not, we show the RUP index data. And here's our layout. So we have a title, H distribution or RUB index distribution, And then we have x-axis title value, and y-axis is title is count. You have this chart layout here. Okay, so update chart, the last method is left. So when the user selects in select showing, yeah, we will use the update chart. Okay, it's actually the same. Okay, it looks like it is the same, so we can just, no, here is event any, no, it's different. Here we take from the select. Okay, good. So now let's see. Let's have a look how it looks like now. So now we have it. We have a select where we can change. Plotly also has its own different here tools embedded. Yeah, as you can see, it's produced by Plotly.js. What is not clear here, why it is not showing the labels, yeah, these labels, x-axis and y-axis title, value and count. I'm not sure if it's so big, this element, that it doesn't fit. Should fit, but for some reason it doesn't show. So we need to find out why it doesn't show. So it should be a title here and an x and y axis. Yes. Let's continue with the next component. We will have a summary table here. So for the summary, we should go again to the backend and create endpoint for the summary. So we go on the patient here, create one more method to get a summary data. So get patient summary. We have the same data. We again filter either municipality and by year. We will drop some duplicates, and we will count total patient. We have with unique, because with the patient ID, unique, number of unique, with return as number of unique patients. Then we filter out only females, only males, and get number of it. We will calculate the mean. So in the pan.data frame, there is already built-in statistical methods like average, standard deviation, mean. So it takes a mean, a row of the age and group, and it returns as a JSON object containing these variables. Now you create the endpoint. The endpoint here, get patient summary. It is ready. We just need to restart our Flask backend, go back to the front end and generate a new component as a summary component. Yeah. And again, generate component summary table. Okay, so we have now summary table generated. Here we have summary table. So to see it, we first go back to our main component, and we say, okay, in the second column, we want to see it. So as you can see, app summary table should be exactly the same name as it given here. So here, if we go to this summary table component, so we will have a table. We will use a table from Angular material table. So here we can go to the table component, and here is very nice, interesting, different tables. Why it's not loaded now? Strange. Okay. Yes. You can have very different styles in the tables. You can add data, remove data, different interactions, remove column, add column. You can sort the columns, you can expand the columns. Okay, there is many different. We can make a search in the table, which is very already built-in search. So they have a different various nice tables here, and we create one of them. So it calls math table. That the data is here, and then we define number of columns. They'll have only 2 columns, which is a summary column and a value of that column. Only 2 columns here. And then we should to show the displayed columns. This is how the rows are building, the header of the table and the columns of the table, the cells. So we need to import here math table module. And we of course will create the data. First we will create interface, label and value, so we can then use it nicely here. Element value, element label. Then we will define, so this is a data, this is a data which will be received from the server with a interface summary. It will do, and then this is what the data of the data table, of the table here, this summary data. We say that the source of the data will be type of summary here, and it's empty now. Now we have to define the displayed columns, label and value. So displayed columns, here the column in name or index. We want to display all of them models, all of the columns. That's why we put all of them here. And now in the constructor, we will of course import the patient service to get the data, and a setting service because we always listen in the changes of the year and region. So now we have to add in our patient service a get patient summary method. So if we go to our service patient, so now we have to create additional method to get from the server the data. Yes, so similarly to the other, we just need to provide the correct name as we have in our upload here in our backend. Coming back, so it will return us the results. So we have to first make it empty, and then we iterate over the result and push it in our some data, and then we says that our data is equal exactly this array of objects. Okay, so we still have some issue. If we go to the descriptive component, we should add also here the summary table component. Okay, So now we go and check it. Yeah, so here we have our summary table. The last two visualization left, a table of individuals, patients, and this graph of events. So let's generate two more components, yeah? But first we go to the backend to get a data for this table first, okay? So we'll go first to the backend. Okay. Go to the patient. So we will call it get patients data. So here we again filter out by region, municipality if we need, by year. Then we select only this data which we want to see in our table: patient ID, age, and gender, right? We could also use other data such as RUB, for example, value, but we don't need it because we will have it anyway in in a time series graph. So and then we send it as a dictionary back, because this is a data frame. We cannot send back a data frame. So we create a new endpoint for this method. Okay, called get patient data. So it's the one that we just used it here. It's ready to be used on the front end. We go to the front end and we generate a new component. And this component, we will name it as a patient table. Patient table. Okay. So now in descriptive test statistic, we will also import this component, and we can add it in our okay. Okay, it is empty. So here we will have again a table. So we will have again math table. We will have a column patient ID, the gender, age, and we will have a pagination. Oh, very important here. So how many per page we will show it. Okay, so we have to import first math table component, table module, and pagination, because we also use a paginator there. Okay, now we will have a data with this type received from the server. We create an interface already for this object of patient data. So with this will be a data in our table. Columns we want to display, yeah, ID, age, gender. So we go here, ID, gender, age. And then the paginator is a little bit complicated here. This is how we access the paginator, which is already exists in Angular as a component. Then we will have a settings which will we receive, and selected row, because we will we want to make our table interactive. So we want to, when a person clicked on a row, we want to select it. So now in the constructor, we will use, of course, the patient service. We will use the setting service, and there is one more we need to use to trigger when the row on a table is clicked. So here we subscribe to the settings of the region, and here we have to create get patient data in our patient service now. Patient service, get patient data. Okay, so this is how we, yeah. Then we go back here, we get a result, we create it, we parse the result in this object, which we want to use it on our front end. We assign this data to our table. We have to, yeah, because when we create a table and it's empty from the beginning, because it will take some time to get data from the server, so we have to trigger change to understand Angular that, okay, update the table. I got a new data from the server. It's not automatically update, so we need to update. And the paginator we have to update later. So we put a set timeout, a delay to update the paginator properly. Yes, and then we will have one more method related to when we want to click. Here is missing. Yeah, when we want to click on a row on a table, we want to do something. We want to show a visualization on another component. So for doing this, so in this case, we want the two components was interacting with each other. So we first have to get one more method, get events data. So we have to go again to our backend, to a patient, and create one more method for getting all events for patients. Yeah, this data has like a huge 1 million of records here. It works fast because we use a data frame. We do not use any loops. Loops is forbidden to use when we have a lot of data. Yeah, so we use the data frame data structure, which doesn't use any loops, so it works fast. So here is the code in Python to get the data. To get the data, events data. Here some data preparation, and I will return like this. It will have data about different events for the patient. Yeah. So we create here an API for this one, endpoint. This is the last one in this example. To restart it, go back to our front end. In our patient service, we also create a last post request. Yeah, get events data, which is also same as this one. Yeah, the same name. Okay, so we will get this data, it will return us the data, and we still need to do a little bit more preparation for our next visualization. So here, what we want to do is we want to okay, for high blood pressure, we want to have a different indicator. We want to have here, for example, is Boolean variable if it's high or not. If it's 1, it's high, 0 is not. So it will be Boolean variable. This indicator will be used for the color, to have it red or green color. And it's only for diastolic or systolic, yes, blood pressure. And then in the patient service, we have to set this data, because this data will be stored, this event data will be stored in our patient service. This is how they will be stored. And then they will be accessible in any other component in Angular. This is how we share the data between the one way of sharing the data between the components in Angular. So the patient service owns this data, okay? And other components, they just update this data or subscribe to get this data. So in our case, we will need to create now a new with component, the last one. Which will be events charts. And in our descriptive statistics, we will also add here events chart component. And yes, okay. So here we will use the Apache charts for making that graph. So we just make sure that whenever we have a data, then we show it. If no data, we don't show it, the chart, in this example. So we used here two components. We use the eCharts component, so we have to import, and we use the if directive. Yeah, here we have a condition here. So if we have it, you show it. If not, we don't show it. And then for the eChart, we have to use this provider. Okay, so now we have these variables for eChart data and also for, yes, okay. Okay. So we have a patient service and settings. So we go to new settings, patient individuals events. We go to individuals events. We set up the data and we show them, show the graph. Yeah. Okay. So we will have very big one method for the symbols generations. So this is how we generate different symbols for different type of events that we have. For the root index, we'll use a circle, and we define here some rules which color it would be. For systolics, we will use a triangle. So this is how we do a triangle, and we also specify which color it will be. The same for diastolic. For hypertony diagnosis, we'll use a square shape, a diamond for screening, diamond for Vict, diamond, and there is, yeah, a round rectangle for others. Okay, and the graph itself is built here. Okay, this is the graph. We have its options. We have a tooltip. Which means is when we want to hover all of these symbols, it will show us something. We have a title. We have the axis defined. It's every month in a year. axis is what type of data and the data itself. Yes. Okay. So let's see. Up events charts. Up events charts. In descriptive statistic, if you move to descriptive statistic, yes, I think events charts component. So you hate events chart. Okay, up events charts. Okay, it looks fine. No, we use the same class. Event charts component correctly. I forgot something. Or I will just do like this. It is included. Okay, maybe. Okay, it's misspelling. Okay, this is charts. It's a misspelling. Doesn't exist. So here I should be S or S. Okay, yes, now it's working. Let's look. It takes now longer time because it's because of Plotly.js library. So whenever we have in Angular, we go to the bar chart, like we are using and importing something like this directly from a JavaScript, it slowed down a lot the Angular application. So here we have a table with a pagination, so we can navigate, we can click. Nope, we can't click, click is not working. Let's see, what did we miss something? Okay, it's not working yet, the click. Let's have a look why. So we go to the patient table and here is click. Let's first figure out if we did click or not. Here. Okay. Okay, inspect. Console. Okay, we are inside, so it is recognized. Okay, we are inside. Patients get events data. Then we have the result. Let's see if we get something. What's going on in our backend? Okay, what's going in our backend? Okay, looks like we sent some data. Let's have a look. Okay, if we send back some data. Okay, yes, we get the data, get the date, event, month, municipality, and patient ID. So we get everything: date, event, month, patient ID, and value. So we got the data. Set individuals events. We have signed it and updated. If you go to events charts, so whenever we updated them, we should come here, right? It could be that I forgot about CSS in this case. Yes, That's I forgot. So for each chart, we should specify the width and height of the plot, especially when we have if. So if it's not from the beginning created, and we will create it later, so you have to specify, still reserve a place for it. I think this was the issue. So now we can make it. So, yes, now it shows here. Okay. Oh, here we have two values, and one of them is high, one of them is not. Measurements. Okay. This is how one very simple example to create a visualization dashboard of the data. When we have a lot of data, for data science, it's very meaningful and very needed to not only look on the numbers and the tables, but also find in the data which is not visible by looking just on the numbers and a huge amount of rows in a table.